Wheat is one of our most important food sources. It provides 20% of the worldwide consumption of calories and protein.
And it's the largest crop in Oklahoma.
That's right. Over 4 million acres of wheat are planted each year here in Oklahoma, producing 115 million bushels.
That's enough wheat to feed 50 million Americans a year. And that doesn't even count its role for grazing cattle.
With the importance of wheat, it's no surprise that Oklahoma State University conducts world-class wheat research, development, testing, and training.
An important tool on their wheat program is field trials.
OSU Small Grains Department has test fields all over the state, allowing them to test in a variety of climates, soil types, and weather conditions. At these test sites, they conduct field trials for different varieties and management practices.
We visited the OSU South Central Research Station in Chickasha to find out more.
Here we caught up with Dr. Amanda Silva, Tyler Lynch, and Yuri Barbosa on a day where they were planting field trial plots.
This field will test 44 varieties.
Each variety gets 4 different plots scattered throughout the field. These replications are used to offset minor soil variability within the field. Each plot is 25 feet long by 7 rows that are 7.5 inches apart. They are also testing management techniques, so they are planting even more plots, testing different seed planting rates and fertilizer amounts. Sections of test plots are surrounded by alleyways that are all planted with an OSU variety called Uncharted. This variety acts as a buffer from trial areas, and it matures at a slightly redder color, making it easier to delineate from the test varieties.
To plant the wheat seeds, this machine is used. It's called a drill.
Like the planter implement you saw in our cotton planting video, drills are used to plant a field with seeds. Both of them open up a seam in the soil, put in seed, and cover it back up with soil. The difference is a planter places each seed individually at set distances apart. So within a row, all the plants are at a set spacing. With the drill, seeds are metered in evenly but not individually placed, so the spacing isn't as precise.
Mr. Tyler explained how the drill works.
With the variety trials, we plant individual plots, and so to be able to do multiple varieties, we have this cone system. So we weigh out every individual plot, and we will dump the seed into the cone. The cone is calibrated from a chain-driven or ground-driven, so we're able to calibrate to go a specific distance. So we're able to evenly distribute that seed out for each individual plot. So once the seed gets dumped into the cone, it's gravity fed and evenly distributed out to each tube, which distributes each tube is connected down here to each furrow unit. And so you, like a normal drill, you have the openers where it opens up the soil down to the bottom of the furrow. The seed drops down by gravity, and then we run liquid fertilizer. So we have an electric pump that's calibrated to about 5 gallons per acre with ammonium polyphosphate, which is just a starter fertilizer to be able to get the seed up and going. And then we have just a typical closing wheel. So once the seed's dropped into the furrow, the closing wheel comes over and basically closes soil over top and firms it down to get good seed-to-soil contact.
So let's see it in action.
Tyler is operating the tractor, but is actually being steered by GPS, which keeps the tractor exactly on track for the carefully mapped out test plots. Yuri is riding on the back. His job is to load the cone with seeds. There's a seed packet for each test plot.
This box is just one of 4 like it. That's a lot of seeds.
Here's the plot number, and then the name of the variety, and then the location. So This will be another one. So this is an experimental line from OSU. So this is what I was telling you, that it's not released yet, but it could be released depending on the information we gather from this season.
It is a lot of seeds, and being organized is very important to this process. It takes good planning, preparation, meticulous record keeping, and careful field work to get good data from these tests. That includes close monitoring of the entire process. Here, the drill operation is being checked to make sure the planting depth is correct. In this case, at 1 1/4 inches, and that the seeds are making good soil contact.
In a few weeks, the parts of the field being planted today will look like this.
This is a section of test plots planted earlier for foraging test. All of the wheat varieties grown here are winter wheat, meaning they get planted in the fall and grow over the winter. As the wheat grows over the winter, cattle can be turned out to graze on it. It's a nutritious way to keep cattle fed and growing. During this period, the wheat is in what is called a productive or vegetative stage. What the cows nibble down, the plant regrows, just like the grass in your lawn. After a sufficient amount of cold weather, the next stage is triggered. This is the reproductive stage. This is where the wheat grows to its full height and produces a head with kernels. A sign that the wheat is transitioning from the vegetative to reproductive stage is something called the first hollow stem. That's the initiation of the stem elongation, when the head starts to move up in the stem, creating a hollow. The farmers monitor the wheat plants, and when they see signs of the first hollow stem, they know it's time to remove the cattle. Letting cattle graze too long on the wheat can reduce grain yield. When a wheat will begin first hollow stems depends on many factors, including its variety, so that is one of many pieces of data collected during field trials. Other data and observations recorded include forage yield, grain yield, germination, maturity, test weights, disease resistance, lodging, and protein content.
All the research results and links to virtual field tours can be found on their website, wheat.okstate.edu. You may be wondering how all this data is used.
Some of the trial varieties are in a development stage and have not been released to the public for planting. The field trials help the wheat breeders know how a new variety is performing and can help them determine whether or not to advance its development. Some varieties being tested have already been released, and the results from these field trials can help wheat growers make selections for their fields. And of course, testing management practices also helps growers make other decisions besides what varieties to plant.
Improving wheat performance does not just benefit the growers.
We all benefit from higher wheat quality, a more abundant and secure food supply, and more sustainable production, resulting from more wheat grown with less required inputs. Thanks, OSU Small Grains, for all of your work on improving wheat production.
And for spending time teaching me about it. See you next time.